Hello, and welcome to another episode of Tier Nerds Tier Lists. This time, I'm branching off from anime and games. I'm going to start doing that a little more often now. And this is a tier list on math formulas or formulae, if you want to get fancy. So some of them are really simple, like you've probably seen them before, like slope intercept form. Some of them are really complicated, like some of like Black-Scholes formula and this logistic growth formula here. Yeah, so I'm gonna go over. So I'm gonna start with simple ones, and we'll just see like where I'm gonna put them. Um, I'm pretty much gonna grade them on just like how cool they are, basically, and all of that. So yeah, so let's see. Let's start with something simple. Let's start with like the circles, for example, like area of a circle, a equals pi r squared, and then we have the circumference of a circle, c equals pi times diameter. So they're both pretty simple, um, kind of boring. I mean, they're useful formulas, like the fact that pi was found and all of that. That's pretty cool. The fact that they did that. Some smart dude back in the past figured out a lot of this stuff for us. And yeah, so I think the area of a circle, maybe I'll give that A tier. The circumference is a little more boring, but it still has its purpose. So I think A tier for the area of a circle, and for the circumference, I think I'll get that B tier. And this might change as I go. Yeah, so that's the first one. Let's see. Then we got Pythagorean theorem. So we're gonna start with the simple ones. So Pythagorean theorem is like, I think it's overused, but it's still pretty important. For anytime you have like a 90-degree angle, yeah, in a triangle, it's just very useful. It has a lot of purposes. And I think there's like 40 something different proofs for the Pythagorean theorem, and one of them was even found by a president. I think President Garfield or something was like really good at math, and he has he made it like his own proof of the Pythagorean theorem. So it's pretty interesting. So yeah, it's kind of overused, but it is useful. So I think I will give that A tier as well. I don't know if I'd give it higher than the circle formula. I might, but it's pretty cool. Yeah, it's kind of hard to decide. They're both A tier. They're both useful. A bit overused, a bit overrated, but like because they're just so commonly used. But they're pretty important as well. Let's see. Then we got a lot of other formulas, like so. I'm just going to the basic ones, like that most people would know from school. And before I move on to like the really, the more complicated ones. Um, See, then we got the slope formula, which it's pretty cool too. I think that one it's a little more boring, so I think I'll put that in the B tier because it's a pretty simple formula for just determining the slope of something or the average rate of change, which is actually important in some ways because that when you get to in calculus they do use that concept of average rate of change. But this is the algebra concept of it. Very simple, just rise over one. So very, very simple. There isn't really much to it. Um, let's see. Then we've got the slope formula, y equals mx plus b. This is really overused as well, but very useful. Pretty much all formulas that you'll see, equations, they're written in this format. And so many uses for it, in stats, linear regression, and just pretty much a lot of math is just revolves around having equations written in this format. A lot of research, and it's always y equals this plus this x plus b, and so it's very simple. If it's a simple line, now obviously there's many graphs that are like lines way more complicated than just simple linear equations. You got quadratics and cubics and all this other stuff, but in its most basic form, the slope intercept form is pretty useful. So I think I'll give it kind of a low A tier right here. Um, yeah. So let's see. That's another simple one. Let's see. Then I think we got this distance formula here, which is really cool. It's not used very often. It's not used very often, the distance formula. But if you have 2 points on a graph, you can, if you know the coordinates of both points, you can actually find the distance. So it's x2 minus x1 squared plus y2 minus y1 squared. So it's pretty cool. You can find the distance of 2 points on a line. So this basically uses the Pythagorean, in some ways it uses like the Pythagorean theorem in a way. That's they're kind of interrelated here, but so there's a purpose behind it. So it's pretty cool. It's a pretty cool formula. I think I'll give it like upper B tier. Let's see. Then we've got now we're getting to the harder ones. So let's start with quadratic. Now this one got cut off. I think I'm going to give quadratic S tier. I think it just looks really cool. Um, so and it's used a lot. Like a lot of people I think memorize it especially if they've taken a lot of had to take a lot of algebra. Negative b plus or minus square root of b squared minus 4ac over 2a. Yeah, quadratic formula got cut off here unfortunately because it's kind of long. But yeah, so quadratic form I think I'll give S tier just because it's kind of cool. And like it looks kind of complicated, and it's kind of cool how you can just use it to solve equations so simply. So this has a lot of applications, especially like in physics. Yeah, like just pretty much in anything involving factoring. It's actually got real world applications as well. So it's a pretty cool formula. Then we've got, let's see, I'm getting to the harder ones. Let's do E equals mc squared. I mean, just it's simple out of physics, but um, I don't know. It's like, should I give it S tier? I'm thinking either S tier or A tier because it's kind of a boring formula. It doesn't look very complicated, but the fact that something in physics and in real life could be explained so simply with just a simple formula like that, it's kind of interesting. It's kind of profound in a way that something so simple could describe something really complex. So in that regard, I think it is pretty cool that it's it could be done like this. So I think I'll maybe give it upper A tier, but I think it's really cool that something so simple could describe complex things. Let's see. Then we got I squared equals -1. So this is pretty interesting. Like the fact that you can square an imaginary number and just it becomes real. Like that's kind of crazy. Yeah, even though technically the term imaginary was a bad idea, it technically should have been just called something else because it makes you think that the number doesn't exist, which it's kind of strange. Um, but yeah, it's just kind of weird. You square an imaginary times an imaginary becomes real, which it's kind of mind blowing in a way. So yeah, so the whole I squared and the whole imaginary number system, I think is pretty interesting. Kind of weird. So I think maybe give it like a low S tier for that, just because of how just how odd the whole thing is. Um, so yeah, E equals MC squared. I think I'll give it upper A tier, and imaginary I'll put up here. So I think it's pretty cool. So yeah, they're pretty much graded on how just weird or cool the formulas are. Then let's see, we got logs. Logs are pretty cool. Like you could do quite a bit with logs. I don't know if I want to give them S tier or A tier. Um, so yeah, like the more overused formulas I put at the bottom, like the cooler ones, more obscure. I seem to put them at the top or just so logs, like the fact that log of xy is log of x plus log of y. Plus, there's a lot of other log formulas, and just the fact that they all work is pretty amazing. I think it's pretty interesting the fact that all these log formulas actually work, and there's a system for it. Um, so it's pretty cool. Yeah, I didn't put exponential formula in here or anything like that, but maybe I should have because the exponential formula is really cool. I will have another tier list though for numbers, like really cool like constants, and I did put e in there, so it will have its day. So log of xy equals log of x plus log of y. I think that's pretty cool. That anything with logs, it's pretty or exponential function is pretty cool. So I think I'll give it. I don't know if I'm gonna give it higher than imaginary, maybe lower. It's pretty cool. Uh, so maybe I will put a little higher. Um, let's see, what else do we have? So now we're getting to the more complicated ones. I'm going to get this one out of the way because it's kind of simple. This is out of graph theory. I think it's out of graph theory, actually. So this is the number of F is faces, E is edges, and V is vertices. So this is faces minus edges plus vertices equals 2. And the fact that this works and makes sense is amazing. I'm not really into the whole graph theory thing, so I don't know. I can't rate it super high. I'm gonna put an A tier just because I think it is pretty cool. Um, Despite the fact that I'm not really into like the whole like graph theory thing. That's not just my expertise, and I've taken a class on it before, but it was like they can make it pretty complicated. So I just think it's really cool that with like polyhedra, they can do this. Faces minus edges plus vertices equals 2, and the fact that this like actually works, it's pretty interesting. Like, yeah. So I'm not an expert on how this is used very much, but this is pretty cool. So I think I'll give it A tier. Um, E equals MC squared has more significance to real life, so I think I will rate it up here. But yeah, it's pretty cool. So see, so far there's no bad formulas, right? If the formula works, there's no reason to rank it super low. Um, then we got a whole bunch of other ones. These are the more complicated ones. So let's go over the more understandable of them. Now this one looks really complicated. Um, So this one right here, this formula right here, this is the formula for the derivative. Now, normally in calculus, you just use power rule or use some simple trick to find the derivative. That's way easier. This is like the standard form of the derivative, and doing it this way takes more time. But it is pretty cool that this is the basic form of the derivative if you wanted to find it. Um, but and this can be done even if you don't understand calculus. Actually, this can be done with just simple algebra. You can't find the derivative using just algebra, but still, like I always thought this was a more annoying, complicated way to find a derivative when there are much faster alternatives. So that's why I don't rank it super high, because I think it's profound that it exists. Like, that's cool. It's cool that it exists, but it's inefficient because you wouldn't normally use this to find the derivative because there are much better alternatives to finding one. But the fact that there is an actual definition for it is pretty cool. So for these other formulas, like, they're pretty much the fastest way to find it. But this is like an inefficient formula. This is not efficient because there are better ways to do it. Which is why I'm going to rank it down a bit lower, down to about B tier, like B plus, because it's still a cool formula. Um, See, I think I'll rate it like this. And then we've got another physics formula. I'm not an expert on physics, but it does look pretty cool. So gravity times, two masses and distance. So it's pretty cool. I think probably cooler than the E equals MC squared formula. But some of the stuff just goes over my head. So I don't completely get it. But it is pretty cool that, once again, they find formulas for this stuff. They find formulas that work in real life for all of this. Um, Man, yeah, I just realized another formula I could use from physics, probably for acceleration or free fall. That probably would another cool one, but I forgot to put it in here. Um, yeah, so now we're down to 3. Now these ones, if you're familiar with all of these, you could be, if you've taken a lot of math classes. Well, what did I do? If you've taken a lot of math classes, you might be familiar with it. But like, wait, what did I just moved stuff around just by moving my mouse around a bunch. Um, so let's see. Maybe I will leave it here. This is probably a bit lower. Yeah, look, I'll probably leave it around here. I think this is where I want to put stuff. I'm just trying to decide one more time where I want stuff. This is slope intercept. It's cooler than that. Not as cool as this. More useful. Yeah, I think I'll leave it. I'll leave it like this. Actually, this actually has a lot of purpose. Um, Yeah, the slope formula is very simple, but it is very profound. It has a lot of purpose. It just looks a little boring, but it does have a lot of purpose. I think this is where I'll move it to. Okay, anyway, back to where I was talking about. So we have 3 formulas left. These ones here are more generic. Like, if you've taken a few math classes, you've probably seen these, or physics, you've probably seen these. These ones are a little more obscure. Like, these ones you're probably maybe not seeing as much. So this first one, this is actually the normal distribution. It's kind of crazy, like, seriously, that this is what the normal distribution actually looks like. Um, which to me is crazy. Now, I'm kind of biased. I kind of like I like stats. So this one right here, this is a pretty cool formula. So this is like for the normal distribution, and it comes from somewhere. Like the 68, 95, 99.7 rule, all the numbers in the normal distribution, all the z-scores, all of that. Like, there's an actual formula for calculating it. And now you don't think about it because you just use your calculator to do all of it for you, but there is an actual formula. like that it calculates all, and it's really complicated. And we never use it in a stats class, but they just show it to you sometimes, like, hey, this is the formula, and it's pretty complicated. Like, it's pretty cool. So I think I'll give it to S tier just for some attitude because it looks pretty cool. But it's, even though you're never actually going to use it because you just use graphing calculator. But the graphing calculator and all the software, this is what they're using as the basis for z-scores and everything for the normal distribution. So it's pretty cool. Then we got logistic growth. This is not normally how I'm used to seeing the logistic equation, but I do think the logistic growth equation is really cool. It's like a combination of exponential and then logarithmic, so it just shows when one population is like, so something grows exponentially and then it slows down and becomes like logarithmic near the end. So it's a very cool concept. And so logistic growth is pretty cool. So yeah, I kind of want to give it a high score. Like, I'm used to seeing it in a different format where it looks a little cooler than this, but it's still a very important concept in math and stats, I think. So I think I want to give it kind of a high score as well. I'm going to try to decide how I want to adjust these afterwards. Maybe possibly S tier. It just looks really cool. Um, then we've got okay. Now this one's like, I mean, I've seen this before. It's random. I'm used to seeing this one differently too. I've seen it look very different in books. Very complicated formula. This is still very complicated the way it's shown, but all these squiggle lines are all just partial derivatives, and this is Black-Scholes formula. This is used in economics, and it can be used to calculate something to do with stocks. And I'm not an expert on it. One time I tried learning this stuff, but it just didn't work out. But yeah, it's pretty complicated. So it's like economics, calculating like stock prices or something along those lines. It's pretty complicated, and it uses like 5 or 6 different variables. I mean, I remember seeing it in a different format, but this is pretty cool with the partial derivatives and everything. Um, so yeah, it's got its purposes. I think maybe like low S tier. This actually has practical life applications. I mean, a lot of these formulas actually have practical life applications. The ones near the bottom of the list are just more boring. You don't use them very much. This one's just inefficient. The derivative formula. So let's see. I'm going to see how I want to adjust these. This one I probably will rank a bit lower. So these ones are just boring. This one is just inefficient. This one I just don't. I wouldn't use it very much. These are a little more boring, but they have a lot of purpose. They're used more frequently. This is just for being famous. Put the two physics equations here. But the really cool stuff I put up here, like logs, quadratic, and imaginary numbers, normal distribution, logistic growth, Black-Scholes formula. So that's where I would put like the cooler stuff, the S tier formulas. Um, so I don't know if I'm putting normal distribution. Quadratics is overused a little bit, so maybe I will put like normal above it, and maybe like logistic and yeah, they're not used as much. Logistic growth. This form of it is kind of boring. It's not. It doesn't look as cool, and so maybe if it was written in the cooler form, maybe I'd rank it a bit higher here. Quadratic logs. I kind of like logs more. Like, all the log formulas are really cool. Imaginaries, quadratics. Yeah, I think it's pretty cool. I think it's around here. So yeah, this has been a really random tier list, but this is one on math formulas, and stay tuned for more random stuff. I'm thinking of another video with like numbers, and then another one with flags or currency, or just some random junk like that. Okay. Well, stay tuned for more.